Hi, and welcome back to First Year Microeconomics. So far, we've used a graph to represent demand. The graph has been called a demand curve. What we're going to do in this presentation is use mathematics to represent that same information. We're going to be using a demand function. Here's our definition of a demand curve that we've been using for the last few presentations. A person's demand curve for a product shows, given the price of the product, how much of the product that person would like to buy, holding all other relevant factors fixed. The demand function is going to do exactly the same thing as the demand curve. In other words, a person's demand function for a product shows, given the price of the product, how much of the product that person would like to buy, holding all other relevant factors fixed. Just like our demand curve, the demand function has price taking built in, it shows the person's plans, and it holds all other relevant factors, price of other goods, income, tastes, expectations, and so on. It holds all of them fixed. In fact, the demand function and the demand curve have exactly the same information. You can use either a demand curve or a demand function in economics. As you get into more advanced economics courses, you'll find the mathematics actually becomes easier, and so you'll probably want to use demand functions. But in this course, you can either use the demand curve, the graph, or the demand function, the maths. Let's start by looking at Jackie's demand function. We're going to represent it in abstract form. In other words, we're not going to use a specific formula, but rather we're going to have Jackie's quantity of apples over here on the left-hand side, represented by the variable QA, and we're going to write that as a function of these variables on the right-hand side. The variables on the right-hand side include the price of apples. In other words, the quantity of apples that Jackie would like to buy depends on the price of apples. It's also going to depend on the price of bananas, the price of ice cream, Jackie's income, which we'll represent by this variable, capital Y, Jackie's tastes, and Jackie's expectations. Our helpful assumption was that Jackie's demand curve slopes down. What does that mean for Jackie's demand function? Well, that's helpful assumption is captured by this partial derivative here. The partial derivative of the quantity of apples with regards to the price of apples is negative. Or in other words, as the price of apples goes up, Jackie would prefer to buy fewer apples. As the price of apples goes down, Jackie would like to buy more apples, which is the same as saying the demand curve slopes down. What about substitutes and complements? Well, here we've got Jackie's partial derivative of the quantity of apples with regards to the price of bananas. It's positive. It's greater than 0. That means that apples and bananas are substitutes for Jackie. In other words, as the price of bananas goes up, Jackie wants to buy more apples. As the price of bananas goes down, Jackie wants to buy less apples. That's what this partial derivative being positive means. What about for complements? Well, this second partial derivative down here, which is negative, tells us that the partial derivative of the quantity of apples with regards to the price of ice cream is negative. That means that ice cream and apples are complements for Jackie. In other words, as the price of ice cream goes up, Jackie will buy fewer apples. As the price of ice cream goes down, Jackie will buy more apples. That's what this partial derivative being negative means. Apples and ice cream are complements. What about the effects of a change in income for Jackie? Well, that's captured by the two partial derivatives here. The first partial derivative says that the quantity of apples rises when Jackie's income rises, so that apples are a normal good for Jackie. Income goes up, she'd like to buy more apples. Income goes down, she'd prefer to buy less apples. That's what this partial derivative being positive means. The second partial derivative is the case if apples are an inferior good. The partial derivative is negative, so if income goes up, Jackie would prefer to buy fewer apples. If income goes down, Jackie would prefer to buy more apples. And that's the definition of an inferior good. So whether apples are an inferior or a normal good for Jackie is captured by the partial derivative of Jackie's quantity of apples with regards to her income. Often, we will just want to concentrate on the quantity of apples as it varies with the price of apples. In that situation, rather than writing down the whole demand function for Jackie, we will use a reduced form demand function. Here's a reduced form demand function in abstract form. Notice that we've simply omitted all of the other variables. So we've got the quantity of apples demanded by Jackie and how it depends on the price of apples, but we've hidden the other prices or the price of other goods like bananas, the price of ice cream. We've hidden her income, her tastes, her expectations, and so on. That's obviously going to be much easier to deal with. And down the bottom here, we have a simple example of a reduced form demand function. It's a simple linear demand function. How would you read this function? Well, it says that Jackie's quantity of apples, the amount of apples she would like to buy, depends on the price of apples according to this formula. For example, if apples were free, so the price of apples was 0, Jackie would like 100 apples. If the price of apples is 10, Jackie would like 100 minus 2 times 10, which is 20. She'd like 80 apples, and so on. If you've studied mathematics before, you may have been a bit confused by the diagrams that we've been drawing. Normally, when you draw a function, you have the independent variable on the horizontal or the x-axis, and you have the dependent variable on the vertical or the y-axis. Now, for a demand function, the independent variable is price and the dependent variable is quantity. Our question is, given the price, it's exogenous or independent, how much would Jackie like to buy? How does quantity depend on price? But we put quantity on the horizontal axis and price on the vertical axis. Now there's a good reason for that, and we're going to find out later on in this course that we can reinterpret the demand function so that in fact quantity is the independent variable and dollars becomes the dependent variable. So we haven't made a mistake, but it does mean that rather than dealing with the demand function, it's often more convenient to deal with what we call the inverse demand function. That's going to flip the axes like in our demand curve. Here's an abstract form of the inverse demand function. The price of apples will depend on the quantity of apples demanded. And here's a simple example. This is the same rule as we had in the previous slide, except now we've inverted it so the price of apples is on the left-hand side and the quantity of apples is on the right-hand side. We call that an inverse demand function. Final point before finishing this presentation. For a first-year course, it doesn't matter how you deal with the problems. Graphically, mathematically, you can use words and logic, you can use tables. The important thing is the economic intuition to understand what's going on. But as you get further and further into economics, the maths really does help. What the maths does is it forces you to carefully set out your assumptions and how you get to your conclusions. So, if you can handle the mathematics, I suggest you at least try and do it in parallel when you go through this course.